Today we want to do something called probability. Now I have a question here. A cupboard has 7 white cups and 5 brown cups. 7 white cups and 5 brown cups. All are identical except for the colors. There was blackout in town, and Mrs. Kamau selected 3 cups, one after the other, without replacing the previous ones. Now, question 1 or question A, draw the diagram for the information. Now, Mrs. Kamau had to take three cups from the cupboard, and the cups are identical. Now she doesn't know which cup to take for the first time, and there is a blackout. That means she may take any cup for the first picking. Now for the diagram, you will have, if that is my cupboard, the first thing, Mrs. Kamau might pick a white cup or a brown cup. Mrs. Kamau might pick a white cup or a brown cup. The second picking, when the first picking she has taken the white cup, she may again repeat the white or brown. Or when the first picking she had taken brown cup, she might take white or repeat the brown. The third picking, on taking the white cup, she might repeat the white, the brown, or there also white, brown, white, brown, white, brown. Now we want to fill in the probability tree diagram. This is what we call the probability tree diagram. We are told that there are 7 white cups. Now the probability of picking the first picking the white cup is 7 over the total. That is 7 plus 5, which is 12. Now it is 7 over 12. Then of picking the brown cup is 5 over 12. Then the first pick she had taken a white cup. That means the number of whites has reduced by 1 because there is no replacement. Now the number of cups has reduced by 1. Now the number of white cups are now 6, but the total also has reduced by 1. Now the total is now 11. Find that now the probability of picking a white cup is now 6 over 11. But here she had taken only a white cup. That means the brown cups are still intact, meaning there are still 5, but the total number has reduced to 11. Now it is 5 over 11 of picking that. Now let's come here. Now taking the brown, but she needs white. Takes the brown, but she needs white. That means the number of white is still intact, which is 7, but the number of total number is 11. Now the brown cup, she had taken a brown cup, meaning taking another brown cup, this one here will reduce. In taking another brown cup, this one here will reduce to 4. Now the probability of picking the brown cup there, the second picking of brown cup, will be 4 of 11. Now we are in the third pick. This means this is the first pick, this is the second pick. Now here is the third pick. Now in the third pick, she had taken white here, and she needs another white here. That means the number of white will reduce here to 5, but the total here is now 10. And brown taken white. If you look here, she had taken white, white, white. That means in this branch there is no brown taken. Now the number of brown will still remain to be 5, but over 10. Look here, she had taken white, brown, but she needs white. She had taken white, brown, but she needs white. That means the number of white which has reduced now, which is 7. The number of white here is 7 over 12. Taken brown, meaning here the number of whites here is 6 over 10. The number of brown is only taken 1, meaning it remains 4 over 10. Look here again. She had taken brown now and taken white. Now she wants another white, and the white at this point is 7. That means the probability of picking another white here is 6/10. Then this one here, she had taken brown. She had taken brown and white. She needs another brown. Now the brown is the probability here was 5/12. Now we find that this one here 5/12, and meaning it remains the probability of picking another brown is now be 4/10. Then the next one, at this point she had taken brown, another brown. Now she needs white, and this brown 5/12, one removed 4/12, then another one removed, meaning the brown here will remain to be 3/10. Then this one here it will be now brown white, meaning the number of white are intact. That means it is 7/10. Now for you to know that your tree diagram is okay, every branch must add up to 1. For example, if you look at the first peak, the first branch of the first peak is 7/12 plus 5/12. If you add that is 12/12, which is 1. Here also 6/11 plus 5/11, you add all, you find that it is 11/11, which is 1. 7/11 plus 4/11, add, it is 11/11. 5/10 plus 5/10, that is 10/10. 6/10 plus 4/10, that is 10/10. 6/10 plus 4/10, 10/10. 7/10 plus 3/10, 10/10. Now that is how we can know when we are correct. Now the next thing we need to give out the outcomes. Now this outcome, if you follow this route, follow all these branches this way, you will find that it is white, picking white. The first pick is white, another second pick is white, then the third pick, the last pick is white. Now they are all white. Then if you follow this branch here, from this part, follow this branch here, then come this way, you find now it is white, then brown. If you follow this part here, follow this, white, brown, white. Now this one here becomes white, brown, white. Then if you follow this wire, white, brown, brown. Now here is white, brown, brown. Then if you follow this, it is brown, white, white. This one here is brown, white, white. Then again follow this one here, brown, white, brown. Now let's begin brown, white, brown. Then this one here, you follow this one here, brown, brown, white. Now this one brown, brown, white. Then this one here, brown, brown, brown. Now that is brown, brown, brown. Now those are the outcomes. Now the tree diagram will help us now to answer the questions, or to the probability, to calculate all these probabilities here. Now the first question was to draw the tree diagram, and this is the tree diagram that they wanted, those 2 marks. Then number B, calculate the probability that she chooses part 1, 2 white caps and 1 brown cap. Now look where there is 2 white caps in this your tree diagram, in this your outcomes, where there is 2 white caps and 1 brown cap. If you look at this part, there is WWB, that is 2 white caps and 1 brown. WBW, that is 2 white caps and 1 brown. If you look BWW, that is 2 white caps and 1 brown. Now I have the 3 outcomes there: the white, white, brown, white, brown, white, and I have brown, white, white. Now at that point I say that the probability of 2 white and 1 brown is equal to white, white, brown, P of white, white, brown, or P of white, brown, white, or P of brown, white, white. Now, the next thing, the word or means addition in probability. Now that means the probability of two white and one brown is given by the probability of white, white, brown plus probability of the white, brown, white plus probability of brown, white, white. Now, how can you calculate that? Now we follow these terms. We follow all these terms. The tree. We follow all these tree. White, white, brown. Where is the white, white, brown? This one here. We follow it from this point. We find that probability of white, white, brown is 7 over 12 times 7 over 12 times 6 over 11 times times 7 over 12 times 6 over 11 times 5 over 10. You follow its root, times 5 over 10 plus the next one is this one here, which is 7 over 12 times 5 over 11 times 6 over 10. You add again 2, you follow another root, you see this root here, you follow it, you follow this root here from this point as you come at this point. That is 5 over 12 plus times 5 over 12 times 7 over 11 times 6 over 10. Let's calculate these things now. Let's calculate 7 over 12 times 6 over 11 times 6 over 11 times 5 over 10 times 5 over 10. What is that? 7 over 44. Here it is 7 over 44 plus 7 over 12 times 5 over 11 times 6 over 10 times 6 over 10. That is another 7 over 44. That's another 7 over 44. Here is another 7 over 44. Then the next one plus 5 over 12 times 7 over 11 times 7 over 11 times 6 over 10 times 6 over 10 times 6 over 10 is another 7 over 44. 7 over 44. Now you add all that. Now I can say it is 7 over 44 times 3 because that is 21 over 44. The probability of picking 2 whites and 1 brown is 21 over 44. The next one, I think you've understood part A. The next one, 2 brown cups and 1 white cup. 2 brown cups and 1 white cup. Look here, 2 brown cups, and yet tree diagram, 2 brown cups. Now if you look here, there is BBW, that is another point we want. BBW, then we have WBB is another one. WBB is another one. And BWB. Those are the only trees or the only branches containing 2 brown and 1 white. Now you just follow. You say that probability of 2 brown and 1 white is equal to probability of BBW or P over BWB or P over WBB. Now, as I said long ago, is that or present a plus. Now we will replace it, the plus there. Now you follow the roots. BBW is 5 over 12 times BBW is 5 over 12 times 4 over 11 times 7 over 10 plus I want BWB is this root 4 over 10, nimeanza na hapa 4 over 10, then it goes this way to 7 over 11, then it goes to 5 over 12 plus the next one is that is BWB. The next one is now WBB here, which starts with 4 over 10 times 5 over 11 times 7 over 12. Now you calculate that. That is 5 over 12 times 4 over 11 times 7 over 10. What's the answer there? 7 over 66 plus 4 over 10 times 7 over 11 times 5 over 12. 7 over 66 again. Then plus 4 over 10 times 5 over 11 times 5 over 11 times 7 over 12. That is another 7 over 66. Now you add them, and I can just say 7 over 66 times 3. That is times 3. What is that? 7 over 22. The answer is 7 over 22. Then the next one, I think you've understood that. The next one, anyone who have not understood will tell me where, and I'll repeat. The next one, number part 3, B part 3, saying at least one white cap. That means at least means it might be 1 or above 1. At least it might be 1 or above 1, but not below 1. Now that means anywhere there is white. Now remember, in all these, look here, in all these, from this part up to here, there are white. That means all these trees contains white, meaning we need all of them. Now to calculate these ones here might take a lot of time, but the only one which has 0 white is the last one. Now we can say at least one white can be the probability of having both brown, all of them brown. I mean 1 minus the probability of having both the brown, because all of these branches contains at least one. Ukiangalia hapa, all are white. Here I have 2 white, here 2 white. one white, two white, one white, one white again. Now that means the only branch which contains no white is the last branch here. Look here. Now this last branch, for us to minimize our calculation, we only take the last branch. We calculate the probability of getting all to be brown, of which will be 5 over 12 times 4 over 11 times 3 over 10. Then this one here, we minus we minus it from 1. Then we'll get the probability of at least one white. At least one white. As you know that at least that means you can have even more, but not below 1. 5 over 12 times 4 over 11 times 3 over 10 times 3 over 10. What is that answer? 1 over 22. Now find here is 1 over 22. Now 1 minus that. Now 1 minus 1 over 22. What is that? 1 minus answer. 1 minus 1 over 22. That is 21 over 22. And that is now the probability of getting at least one white. Now that is it. Completed. The first one completed.